Okay, so I believe you can start. Welcome everyone. I'm Dariusz, but you may know me as Carrot. I'm a main creator of PHPCS Fixer. Gladly we have a lot of contributors, so it's not one-man job. And I would like to share with you little idea, little concept that we grew up in the project of PHPCS Fixer during last 6-7 years. Basically the project itself right now is not that trivial, not that simple, not that small. Like in terms of numbers, we have 200 different rules to make code look better, work better, but somebody had to review those 200 rules first. So during that time, we had a lot of different issues how to ensure that quality of the tool that is supposed to embrace quality of the tool of the other project will be good as well. So treat this as a share of the idea, not as an ultimate solution, what to copy-paste into your own projects. Here I will not like to share to you what exactly PHPCS Fixer does, but how we ensure to merge only good code to PHPCS Fixer and how to reduce time during the review process. So first of all is why we would like to automate things. One thing is that we don't want to overlook something. It's so easy to remember something when you just came up to the issue, and then half a year later you don't remember about this one particular problem you faced 6 months ago. So we can try to automate that, and you no longer need to remember that yourself. Then, if you even would remember, you would need to ask people to follow this. So you don't need to ask the people, you don't need to spend your time for asking different people to do it, if you can automate something. And finally, people don't like criticism. If I went to somebody asking him, hey, maybe this is not ideal, do this or that, it will be better because this and that, they can take it personal. If the same input would be given by automated tool to everyone, they are sure there is no bias involved. They are more open to get that criticism. One thing to remember is that the auto review itself will not replace review process. It's only to make it less absorbing, to make it faster, to not involve the main contributor for every single line proposed to be changed. So what we can automate? One of the things we can automate is to check project in given environment with given configuration. And then, of course, the code itself. To do it, we often run automated tests. For example, with PHP unit, we often have some linters, like check bashism if we have some bash scripts for helping us. And then static code analysis, for example, PHPCS Fixer, because we are just talking about this case. But that's not everything we can do. So what more we can have? What more we can start automating? Everything that so far we were doing manually. Like, for example, if you for every single PR need to check if documentation was updated, this is something you can automate, put inside your CI pipeline, and don't need to remember it every time. You can just ask your CI automate to do it for you. Then everything you asked multiple times for the contributor, hey, can you please do this? If you ask multiple times, even different people, this is also something you can save time on. You can just ask a CI to asking for you. You can save time on it. And then especially the little things that are super easy to forget, maybe sometimes a matter of taste, maybe sometimes just some edge case. If you can automate this as well, it would be great. So for now, I was talking mostly on abstract level. So here I would like to present 10 lessons we learned during development of PHPCS Fixer project during last 7 years. Exactly. So first of the rule is we need to check all environments we officially support. It's so easy to say our project runs properly on PHP 5x and 7x, but we run tests only on one environment. then we actually only hope it runs on proper version, but we never checked. So one day, like 5 years ago, somebody raised a concern, hey, you say you are supporting, don't know, PHP 5.3, but Travis updated the CI job to run PHP 5.3.6 and not 5.3.3. So we failed. So we can ensure we test everything we promised by having a matrix on a given CI. But this is of course not just for the PHP engine itself. Imagine you have different databases. Imagine you have different services. Maybe you don't bind your service to one concrete version. Maybe you say you run on version 2+. Keep in mind to check everything, to check more than just one version you randomly selected originally. For example, we have a little spin-off project, PHP unit good practices, that enforce on runtime to not use deprecated features or weak checking on PHP unit itself. But here, we have another actor in game. We no longer check only PHP engine itself. We must ensure that our little library works properly on both PHP, given version, and then PHP unit, given version, because we are a plugin for it. And this creates a huge matrix. Of course, we can try to simplify how to execute this. Not that much need to check every single script I'm gonna share or code I'm gonna share. We have, no point. We have all the links at the bottom. You can check it offline later as well. Here, basically, we select which PHP unit we ask to be installed. We install it. If it's not possible to run it over given PHP engine version, we just skip the test because it was never supposed to run like that. Other lesson is to always check lowest supported environment. The example with PHP 5.3.3 versus 5.3.6 on our CI, and then even if we installed 5.3.3, maybe we didn't install the lowest dependencies we are supporting. Maybe we said we are supporting Symfony Console version 3 and version 4, but we always install version 4. So somebody started using the new functionality added in PHP in a Symfony Console version 4. Nobody checked does it still executes properly on version 3, which we supported, at least which we promised to support. So for example, we can set our minimum platform configuration. If it's not defined, we can install the lowest dependencies via Composer instead of the highest available and run all the commands we were supposed to run normally on the CI level. Next lesson is that we don't longer think, not only think about the oldest things we support, about the oldest version, but we also want to be ready for the future. So whenever somebody deprecated some functionality, we know it's gonna be removed in the future, so we want to stop using it. And what's more, we don't want our contributors to use it in their PRs. So for that, we can use PHP unit bridge from Symfony family that will automate checking it. So we know that if we were using some deprecated functionality, our CI would fail. But it's not about the functionality of libraries itself, it's also about the language. Like PHP unit, PHP, especially recently, is growing like crazy. We release new version, PHP 7.1, 7.2, 7.3, 7.4, and then sometimes it changed how it works. For example, it introduced the strict mode. But then, if your project is not yet supporting only PHP, let's say 7.4, maybe you don't use it. But you can check on the fly, if you would start using it, does it work properly or not? So if somebody is contributing to the project, maybe he is using weak typing, and then some functionality is giving the warnings, so we can escalate that and give not just a warning, but blow up. So one of the way we can achieve it is to automate migration as one of the job on the CI level, and say that we are rewriting whole code base on the fly from whatever version we are using on a production to version 7.1, 7.2, 7 whatever. We transform whole code base, we make it strict, we make all the warnings to be errors, and again, we just run our regular checking commands like PHP unit. If it works, it works. If it doesn't, it means somebody used the legacy functions that will work differently in new PHP engine. Another lesson we learned is about dependencies. When we install dependencies on our local machine, by default we are installing both production and dev dependencies. But then it can mean that one of our dependency, like let's say the Symfony console, if we put it only in dev dependency, the project works for us. But if somebody installs our project, the dependency is missing. So it won't run for somebody else. For that, we can check if all the dependencies we are using are actually properly defined in production dependencies. And if not, we would see the nice error message that we didn't install as a production dependency. Here we have stopwatch, the last line. And for example, we didn't explicitly say that we rely on this or that extension. Next lesson, we just want to make sure that our div is the smallest as possible. So we normalize composer. So everyone that is touching the composer will always have it in the same, written in same way. Something like a coding starts for composer. So we can run the composer normalizer. It will realign, recreate our composer JSON file. So on each repos, on each sub-module, we will have the same format of composer JSON file. Next lesson, kind of the biggest one, because as the most complex one, is doing the auto review as a test. It doesn't collect any code coverage. It doesn't check if your application works properly. We just decided to use whatever tool we actually had already running. Here it was PHP unit, to check a few more things, to make our manual review process easier and faster. So a few things we could check here. Taking this as a template. We just say we don't collect any code coverage here, we don't check anything. It's special auto review group. It can be separated job on the CI level. Example what we can test. In PHPCS Fixer we have 200 rules plus now. So each of the rule is giving some self-documenting definition. But how to ensure that each of this definition is following the same format, following the same approach? Of course, first step is to introduce interface. We have proper interface, we can ensure we always have description, we always have summary, etc., etc. But then, finally, we have a free text. So maybe instead of what's given on the example above, we have just poorly written words. We would like to improve it. We would like to always have a full proper sentence. We would like to follow proper grammar. If we are having some terms used across whole the project, like PHP doc, we would always like to have the same casing of the letters. So if somebody would look at auto-generated documentation, the definition of every of those 200 fixers would be similar. It would be looking the same way. So this is not quality of how our project itself is executing, but what is the experience for user. Example how to do it is to basically iterate over every single fixer, apply some regexes, apply some basic PHP unit assertion to make sure it follows the condition we just set. Like full sentence, we have some examples, we have proper casing. PHP unit is not the only way how we can do it. It can be automated in any way. Just use the tool you are having right now. Another question. We have like 3, 4, 5 different versions supported over the same time. We have newcoming beta version, we have LTS version, we have regular version, and we have next major version. And then sometimes when we synchronize one branch to another, we have the issue that we didn't update the alias of the composer. Like especially for the master branch, it has to have some alias, it has to have proper version. But what is proper version? Over time, depends on your branching model. For us, branching model is always next minor version, next feature release. It means that for whenever we update, whenever we release the new version, this 2.15 would need to be changed to 2.16, 2.17, etc. Somebody has to remember. Few times we forgot. Super easy to forget, especially if multiple people are doing the release. So to prevent that, another unit test. We just check if the file is there. If we have the key must match the application version. Super easy check, like 15 lines, and it saves a few times release issue. Another concern is the quality of tests in terms do we have them. When we have bigger PRs, when we have some nice, cool, new feature that we would like to have, but the code is so complex that we decided to split it across multiple classes. It may happen that actually those multiple classes will not be just 2 or 3 classes. It can be 10 different classes, 5 services, plus 8 DTO objects. And then how to ensure that actually everything is unit tested. What's super easy to look on the PR level is that the main feature service, the main fixer class has tests. We have proper unit tests, integration tests. But for all the small services, it's easy to overlook. So we can just automate, hey, we need to have class for everything, and we have tests for it. We just iterate over defined services, defined classes. We get it as a data provider. We check it's there or not. Then one of the other thing is how we use libraries, how we use frameworks. The frameworks often give you multiple ways how to define, how to use same feature. For example, for PHP console, when we have a command, we can have a constant with a command name that is later registered by set name. We can have a default name as a static property, and Symfony automatically use that feature, but it was introduced later as Symfony 3.4, I believe. And we were still supporting Symfony 3.2, so we couldn't use that yet. And then somebody updated, and we started having different approach for different commands. One command was following the default name as a static property. Some commands we had just the constant, and that's it. So we can unify the form, the way, how we use the framework, how we use our tools across our application. So another simple test just to ensure all commands are following the same approach. And we can go. There's a lot of other things we can test. We can test that our, let's say from top, we have test classes, but we also follow properly interface, meaning that when we have the class that implements interface, it should give only that. It shouldn't give anything more, any new method that were not mentioned in the interface. We can check that we don't expose public properties because we are afraid of encapsulation concern. Or maybe we can say that our CI is testing each PHP version that we support accordingly to composer.json file. So we can come up with any concern we ever face in our development lifecycle and just put it as a constraint in unit test. Then, next lesson is that we need to make sure that we can actually do a release. It happens few times, not only in PHP CS Fixer projects for me, also in corporate projects, that we merged some changes, everything was good, CI was green, we decided to release, it blew up. For some reason, it doesn't compile. Maybe because it's using different compiler. Maybe because steps are different for dev environment and for production environment. So what we can do on CI level is to do some kind of dry run. So we would prevent that we are deploying right now in this PR. Just didn't publish. So we make all the artifacts, we try all the steps during what we would be do during normal deployment, and then we just didn't execute the last step. For PHP CS Fixer, as this is the console application, it's kinda enough to see can we actually do the installation of the package, and maybe can we do the artifact for the composer, because composer sometimes just do git clone, sometimes it's download the tarball. For later case, once we had git attributes with some ignore rules, and then we ignore too much, which means after creating the zip archive, the zip didn't contain every file that was needed to actually execute the file. Quite a few commands. Basically, we check: can we install? Can we run autoloader? Can we execute our logic? Meaning, can we at least check if the application is running using checking the version, and see can we trigger one of the commands. This is kind of smoke test. We don't test everything here because we already tested with unit test and integration test. Here we just check can we execute after deployment. Using those steps, we can again just put this as a PHP unit test, and voila. Later, after having the zip file, we can actually create the far file, and we can run the far file as well. Maybe even compare the outcome, like was the exit code the same, maybe the content of the defing, of the content of the fixing versus original file was the one that we assumed. Lesson 9. It's not just about PHP. We can test more things. One of the things that just drive me crazy because everyone has differently configured IDE is that a lot of times I see just trailing white spaces in some lines, and my Git is crying on the red color. Anytime I do the git diff, I do it in console, I see red pieces everywhere that just drive my attention into, and I cannot focus on the code anymore. So I just decided to automate it. Hey, we follow the rule like we aligned, but nobody was checking, so let's ensure we always trim those white spaces. A bit tricky to not check white spaces in some binary files or let's say .git folder, but totally possible to automate on the PR level. Maybe without going here into that crazy regex that goes on the right screen and another screen and another screen. This is public, everyone can use it. We can set the exceptions, like we don't check, for example, that git folder, and that's it. Apply to CI, nobody needs to remember anymore. And the outcome is quite nice. We just run it, we have the error, something failed on this file, on this line, super easy to fix. So this is kinda checker, linter, it doesn't fix anymore, but we still failed on the CI level, everyone is good. Everyone followed the same rule we aligned. So kinda evolving from this lesson, the 10 lesson, we can go beyond. We doesn't need to stick to the tooling we have. If we have PHPCS fixer, PHP stan, Psalm, whatsoever, maybe it doesn't check everything for us. Maybe it doesn't check the business logic. Maybe it doesn't check the documentation standards we are following. So we can add our logic, we can add our checks to whatever tool we already have. Like we decided to use PHP unit, even if PHP unit was originally supposed to run only unit tests. And for sure, anything I show here was not unit test. And that auto review as a PHP unit code is kind of spreading. I'm not sure if you know, for example, infection library to do mutation tests. They also went with the auto review approach, and they went either further because it's give you so much power to check whatever you want with just code you are daily writing. That is super easy to use. And then, because if we said, maybe we don't have the proper tool for the things we want to check. Maybe we want to use existing tool because it's possible, easy to write for us. But maybe we cannot write, maybe we cannot use our existing tools, like here PHP unit, or we can, but it would be a big workaround and actually not that much friendly. So we can just go totally out of it. We can go away from the product we are writing. We can just write small scripts in whatever language. We don't need to be fancy. This is an example of the buff script that I run in a different project. Project is TypeScript, Angular, single-page application, long-living, never reload. What we can check? Totally nothing in PHP unit. But I want to ensure, for example, everyone use TypeScript and not JavaScript. So we can just make a super small git grep or git list query, grab the outcome. What's important here, we don't just say, hey dude, this is wrong. We say why it's wrong. One of the other example was that we were using in our application some CSS property that had issues with one concrete device, tablet device, that we bought like 3,000. So we bought 3,000 devices, we shipped it to the users, and then we figured out, this property doesn't work. So we could just fix it. Okay, now the application works for user, but is it enough? Like how to prevent the issue happening again in the future? Because nobody will remember that one CSS property is forbidden because some crappy device shipped to users. So we can just make a check, same like here, testing that are we using this property or not, and giving the reasoning, because the reasoning is the clue that people will learn. And with this thought, I would like to say thank you. If you have any questions, I'm here for you. Yeah, please.
Are all those tools and scripts available in the PHP CS Fixer repository or in some other repository?
So basically, each of those checks, if each of those scripts, regardless it was a PHP unit code, regardless it was a PHP CS Fixer or some related but other repository, on the very bottom we have a link to concrete version of it, the blue one. So everything's public, everything's also running on the CI level. So after the conference we can just download the presentation, see how it's actually executing. For me, this meeting with you is to sell the idea. So for sure no need to, copy-paste by hand every single line from the snippet. We can just take the idea, see maybe something is useful for our projects, maybe not. If yes, we can write it ourselves, we can just copy-paste it from repository because it's public, and just run it on our CI. Thank you very much. Anyone? Then I guess thank you very much. If you would like to have contact to me, you can find me on the left side of the screen. You have some business cards on the tables. Just approach me and let's talk a bit.